Trig, we are going to cover the law of cosines, which is a review from Algebra 2, but it's a good review. So we are going to be solving triangles. And when something mentions solving a triangle, it means I'm going to be identifying the measures of all sides and angles. So I should have 6 parts in total. And then there are different ways we can approach solving. So when we're given a right triangle, solving is super easy because I can use any of my trig functions. So I could use SOHCAHTOA. But I also can use my Pythagorean theorem. My Pythagorean theorem is specifically for a right triangle. Oblique triangles are all the other triangles that don't include right triangles. So when we find an oblique triangle, we have to use different methods of solving. So if I have an oblique triangle, but I have the values of a pair, and when I mean pair, I mean an angle and a side, then I can use the law of sines. Now we covered that in lesson, I covered that in lesson 72. So when I have a pair of a side and an angle that are across from each other, I can use the law of sines. Today we're going to be talking about if I have values of a pair not known. And in that case, I will use the law of cosines. Now, once I use the law of cosines and find a pair, then I can use law of sines. All 3 angles in a triangle equal 180. But I might have to start with the law of cosines. So let's go over what that is. I'm going to draw a triangle, and this is the same for the law of sines. So if I have A, B, C, when I say a pair, I'm referring to an angle and the side across from it. So this would be a pair. Angle A and side A are a pair. So if I knew these two things, I could use the law of sines. That means side B would be across from B, and side C is across from angle C. So that's what they mean by a pair. If a pair is not known, then I have to use the law of cosines. So side A squared will equal the other 2 sides squared, so B squared plus C squared, minus 2 times both of those sides times 2 times B. I'm not even going to use parentheses, sorry. 2 times B times C times the sine of angle A, because you still use the side across from its angle. Now there are 3 forms for a law of cosines because it just depends on what side you're using. So this could also be written for side B. So B squared would equal A squared plus C squared minus 2 times AC times the sine of B. But notice you use side B and angle B. You use the pair. And then last but not least, this could be written about side C. So A squared plus B squared minus 2AB times the sine of C. So you could use any of these really. So we're going to practice using all these parts to solve for the following triangles. So number 1, solve for unknown parts in the following triangle. So I'm going to label this X, this bottom is 10, this angle here is 36 degrees, this side is 7, this angle is Y, and this is M. All right, so in this problem, I do not have a pair. I do not have an angle that is across from a known side. So I'm going to have to use the law of cosines. And so I'm going to use the law of cosines for this pair here. So X squared will be equal to the other two sides squared, and it doesn't matter what order you write it. You could write 7 squared or 10 squared first. It's up to you. Minus 2 times the two sides you just wrote times the sine of the angle across from x. So in this one, this is pretty easy. I can just enter everything on the right-hand side. So 7 squared plus 10 squared minus 2 times 7 times 10 times the sine of 36. And I get x squared equals, oh, you guys, I cannot believe. I'm like, something's wrong. I'm using the law of cosines, but I've written sine everywhere. Ugh, this should say cosine of A, cosine of B, cosine of C, cosine. I'm like, that doesn't make any sense. Woo. It's Friday, guys. It's Friday, and obviously my brain, this should say cosine. That's much better. All right, my bad. The law of cosines, this should say cosine. All right, so x squared equals 35.7. I'm just 37. I'm going to write as much of it as possible and then take the square root of that, right, to solve. And x equals 5.98. If you want, you could approximately round to 6, but I'll keep it at 5.98. All right, so I have found x. Now I can use law of sines. Because I have a known pair. You could keep using cosine, but I don't think it's going to help because it's the angles that are unknown. So I'm going to use the law of sines. So the sine of 36 degrees over its pair, which we just found is 5.98, equals the sine of, let's say we look for m next, the sine of m over 7. So to solve this, I cross multiply. So 7 times the sine of 36 degrees will equal 5.98 times the sine of m. And so I'm going to divide both sides by 5.98, right, to solve. And so I'm going to enter this in my calculator. 7 times the sine of 36, and then divided by 5.98, I get 0.688 equals the sine of m. And then you would have to do sine inverse of 0.688 to find angle m. So using my calculator, sine inverse of the answer I just got, and angle m equals 43.5 degrees. All right, so I have angle m, I found x. The only thing left is y, and y is easy, right? Because 180 degrees minus 36 minus the angle we just found will equal angle y. So 180 minus 36 minus 43.5, angle y is 100.5 degrees. So we have just found all three parts. So moving on to a couple more. So the next one. All right, so we are going to solve the following triangle. So this is 5, 7, 8, x, y, z. All right, so this one is slightly different. I don't know any angle. And I definitely can't start with law of sines because I don't know any pair. Every pair that's across from each other is unknown. And for this one, it doesn't matter where you start. I'm going to start with x. All right, so 7 squared will be equal to the other two sides squared, so 5 squared plus 8 squared, minus 2 times 5 times 8 times the cosine of x. So there's our law of cosines. So in this one, I can't simply just enter the right-hand side because I don't know the cosine of x. But I can simplify, so this is 49 equals, let's start with 5 squared plus 8 squared. That gives me 89. And then a negative 2 times 5 times 8, that gives me minus 80 times the cosine of x. So first things first, you can't do 89 minus 80 because 80 is attached to the cosine of x. But I can simplify by subtracting 89 from both sides. So I get negative 40 equals negative 80 times the cosine of x. And then I can divide both sides. So I get 0.5 equals the cosine of x. So we're going to enter the cosine inverse of 0.5. That will give me angle x. So the cosine inverse of 0.5, I get that x equals 60 degrees. So angle x equals 60 degrees. Now I have a pair, so now I can use law of sines. So now that I have a known pair, now use law of sines. And I'm going to do that right up here. So the sine of 60 degrees over 7 is equivalent to the sine of y over side 8. So I'm using these two here. Cross multiply. So I'm going to multiply this side and try to visualize it. So I'm going to have 8 times the sine of 60 degrees divided by 7. That will equal the sine of angle y. So I'm going to enter the left 8 times the sine of 60 and divide that by 7. And I get 0.9897. And so that's when you need to do the sine inverse of this decimal equals angle y. So the sine inverse, I get that y equals 81.8 degrees. Now, to find z, really simple, right? Because all three add up to equal 180. So 180 minus 60 minus 81.8 gives me 38.2 degrees. So 38.2 degrees equals angle z, and we have found all three parts. All right, we're going to move on. We're going to do the next one. Now, this one would be presented like a word problem, and I don't think I have the actual word problem written. So let's say I have this structure. Hold on. And this is this tall pole. And this is 15 degrees. This is 150 feet. This here is angle B. From here to here is 50 feet. And they want X and angle B. So find X and angle B. All right, so first thing, I do have a known pair here, so I do get to use a law of sines right off the bat. So I know that the sine of 15 degrees over 50 should be equal to, the sine of B over 150. So again, we're going to cross multiply. So 150 times the sine of 15 degrees, and I will end up dividing that by 50. and that will give me the measure, that'll give me the, sine of b. All right, so 150 times the sine of 15 divided by 50, and I get that 0.7764 equals the sine of b, so we do sine inverse of 0.7764 to give us the measure of angle B. So sine inverse of the decimal we got, I get 50.94 degrees. Now, this section goes over the ambiguity of the law of sines when finding an angle. What they mean by that is, remember that when it comes to sine, sine is positive in both quadrants. Okay, that's review. But also, you have to take the knowledge you've received but apply it to our scenario. I got 50.9. That doesn't make sense because this is an obtuse angle. So this is not obtuse. Okay, so we have to know that 50.94 could be here, but it also could be here. And so we're looking for, I'm almost done. I'm looking for the related angle. So I'm going to do 180 minus 50.94 to find the related angle in quadrant B, because I know this is an obtuse angle. And so when I subtract, I get 129.06 degrees. That is angle B. So there are times, especially in a real world problem, where you're going to have to look at your answer and ask yourself if that makes any sense. Okay. Now we can find x really easily if I know that this is 129. I can use that pair, or I can use, so the sine of 15 over 50 equals, this is going to be x. I need this angle here, right? That's a cross. So 180 minus 15 minus 129.06. And I get, 180 minus 15 minus 129.06. And I get 35.94 degrees. So the sine of 35.94 degrees. We're going to cross multiply. So 50 times the sine of 35.94 degrees over the sine of 15 degrees equals x. So 50 times the sine of 35.94 divided by the sine of 15, I get that x equals 113.39 feet. And that is it for this section. In homework 81, you're going to skip numbers 11 through 13, number 3, 19, and 21. Thank you.